Hello everyone. Welcome to the 17th lecture, okay, on numerical analysis, that is paper 2 of BSc 5th semester. So now uh, we have seen that we have already completed unit 1, okay. We have completed unit 1, that is solution of algebraic as well as transcendental equations, and solution of system of linear equations. There we have seen iteration methods, Gauss Seidel as well as Jacobi iteration methods. So that is end of unit 1. Now we are going to start unit 2. Now we are going to start the unit 2, that is finance difference. This unit 2 compromises finite difference operators as well as interpolation. There are two topics in the unit 2. So one is finite difference, and the second one is interpolation. Okay. So we are going to deal with the interpolation later and finite difference now. Okay, we are going to deal with the finite difference now. So this finite difference is a very elementary thing. Put it in a systematic manner. For example, if you have a function y is equal to f of x, right? For different x, that is for x1 you get y1, and for x2 you get y2, and so on. Okay, so now if you take this difference, so that is y2 minus y1 and y1 minus y naught, if there is any initial value, say x naught gives y naught. Okay, so that means by putting x naught, x1, so on in place of x, we are going to get outputs as x, y1, y2, y3, so on. So this difference, now we can see y1 minus y naught, y2 minus y1, y3 minus y2, so on. Okay, we are going to get so many differences, and this I am going to write it as delta y1. Okay, and this is delta y2, and this is delta y3. That means delta here, this represents change. Okay, that is the difference between y1 and y0. Difference between y2 and y1 is denoted by delta y2, and this is a Greek letter, capital delta. Okay, capital letter of the delta, and we know that this is small delta. Okay, so these are the Greek symbols which we are going to use them in the operate. We are going to use them as operators. Okay, so this is the operator. So now this difference, so we are starting from y1, y2, so on. We are going on increasing order in the forward way. Okay, so at the last what we are going to get at the last, yn minus 1. So this is the nth difference. Okay, this is the nth difference. So that means yn for xn you will be having for xn you will be having yn. Okay, and yn minus 1, this is given by delta yn. So these are here, these are moving forward. Okay, to yn. So therefore we denote this as forward difference operator. Okay, here in this unit 2, if you, whenever you come across this delta, this is nothing but now the forward difference operator. Okay, so I hope it is clear why it is forward difference. You have seen this is a difference. Okay, yn minus 1 is a difference, and it is moving forward to yn. So therefore it is called forward difference operator. Now you can imagine that you can move from yn to y1. Okay, you can move this way also. So this we treat it as backward, and we'll see that in the later. Okay, so now what is a forward difference operator? Okay, for the values y0, y1, so on, yn, as I explained here. So this is explained here. Okay, so this thing y0, y1, yn of a function y is equal to f of x. So we have considered a function y is equal to f of x. For the equidistance values x0, x1, x2, so on, xn. See, earlier we have taken x1, x2, xn, and we don't know that whether they are equidistant or not. Okay, so now the question comes, if they are equidistant, okay, so that means if x1 is equal to x0 plus h with a common difference h, then okay, so then x2 will be x1 plus h. So what is x1? x1 is already x0 plus h and plus h. So this is going to be x0 plus 2h. So that is x2. So h is a step length, or you can say it is a uh, difference, okay, which is a constant difference. So now we can say that x1, x2 and x3. x3 is what? x0 plus 3h. So they are equidistant. x1, x2, x1, x2, so on, xn are equidistant. That is, so when you subtract these, okay, so you can take x2 minus x1, which is equal to x3 minus x2, which is equal to x4 minus x5, and so on. Each difference is h. So you can see that x2 minus x1 is h. Okay, so x2 is x0 plus 2h minus x0 plus h. So this gives h. Okay, so each difference is h. So then we can say that this is equidistance. That is what the meaning of equidistance. Okay, if the difference between two consecutive values is same in any number of terms, in any number, you can take any xn minus 1 or any term, the difference remains same, then we can say that this is equidistance. Okay, yeah, that is what explained in the here. See, for the values y0, y1, so on, yn of a function y is equal to f of x, for the equidistant values x0, x1, so on, xn, where x1 is nothing but x0 plus h, so this is we have already seen here. x2 is x0 plus 2h. See how it comes, x2 is x1 plus h and x1 is x0 plus h, therefore it is x0 plus 2h. x3 is x0 plus 3h, so on, xn is x0 plus nh. The forward difference operator is defined by delta f of x1. So this is for the first one, that is equal to f of x1 plus h minus f of x1. What is f of x1 plus h? So this is x1 already. x1 is x0 plus h. So this is x0 plus 2h. f of x0 plus 2h means what? So that is something about x2. Okay. So this difference, so this is what, nothing but delta yi, delta f of xi, nothing but yi, is equal to, this is yi plus 1 minus yi. That is what explained here. Okay, so then in particular, if you are going to put a values for I is equal to 0, 1, 2, so on, okay, so then delta y0 is nothing but y1 minus y0. Okay, yeah, so this should be y0, not y1, this should be y0. Okay, and this is y1, this is y2. Yeah, so what is delta f of x0? f of x naught plus h minus f of x naught, that is f of x1. X naught plus h is nothing but f of x1 minus f of x naught. F of x1 is nothing but y1 and f of x naught is nothing but y naught. Okay, so therefore delta y naught is given by y1 minus y naught and delta y1 is given by y2 minus y1. So as we have seen here, y2 minus y1 is delta y1 and so on. Okay, this is called the first forward difference. Okay, so when you extend it to the n, when we extend it to the nth value, then we are going to get delta yn is equal to delta yn minus yn minus 1. Okay, so this is known to be first difference, first forward difference. Why? Just because we are taking it in the very first value of y, therefore it is a first forward. So now we will go for the second forward difference. What is second forward difference? That is delta square f of xi is equal to delta of delta f of xy, delta of f of xi. What is this? So this is nothing but f of xi plus h minus f of xi. So therefore, and this delta is a linear property. That means it distribute over here. So delta of f of xi plus h minus delta of f of xi. So this is f of xi plus 2h minus f of xi plus h minus, and this delta f of xi is f of xi plus h minus f of xi. When you simplify it, this becomes f of xi plus 2h minus 2 into f of xi plus h plus f of xi, that is equal to yi plus 2 minus 2yi plus 1 plus yi. Okay, leave it. Second order forward difference, we shall see this later, so it is not that much of important. Now when you come to the example, you will understand it easily. That means delta of delta, already we know what is delta f of delta f of xi. If you know delta f of xi, that is f of xi plus h minus f of xi. So we are going to repeatedly use this definition. Okay, that means if you want to calculate delta f of xi, you just need to apply this twice. Just need to apply this, apply delta, the operator, forward difference operator, twice, then we are going to get the second order. So if you want to find the third order and higher order, this is the third order, that is again delta of delta square, repeatedly applying delta over delta, then we are going to get the higher order derivative. And the nth difference, nth forward difference, this is very important. The nth forward difference, delta raised to n f of xi is equal to delta raised to n minus 1 f of xi plus h minus delta raised to n minus 1 f of xi. So if you go on putting n from 0, 1, 2, so on, we are going to get the explicit values. Okay, and this when this the differences delta y naught, delta square y naught, delta q y naught are called all leading differences. Okay, so now it is not clear until you get a clear picture of the differences. Therefore, we shall go for the example. Okay, yeah. So now I hope you can clearly see this. So this is the x value and this is a y value. When x is x naught, y is y naught, and x1, y1, x2, y2, x3, y3. Okay. The first forward difference, delta y, that is nothing but y1 minus. So you can see that. So y1 minus y2 is nothing but delta y naught, which is equal to y1 minus y2. So if you take these two difference, y2 minus y1, then we are going to get delta y1. So if you take these two difference, y3 minus y2, then we get delta y2. Okay, so this is the first difference. First, forward difference. So this is the second forward difference. And this is the third forward difference. See, when delta square is given, see, already you know this, delta y1. Next, apply delta for these two. That is difference between delta y1 minus delta y0 is delta square y, that is delta square y0. Okay. If take difference between these two, delta y2 and delta y1, then it is delta square y1. So if you take difference between these two, then this is equal to delta cube y0. Okay. So this is what the forward difference table is. What forward difference table. Okay. Yes. See, this is very easy thing. If you just go on finding the difference between consecutive terms. See, y0 and y1 are consecutive because of the equal step length. Okay. So you must also be careful here. The x1 minus x0 gives you the step length h. So that means these are equidistant. Okay. So x0, x1, x2, so on are equidistant. Fine. So let us see an example. Construct the forward difference table for the following x values and its corresponding f values. Okay. So what is the x value given? 0.1. When x is 0.1, it is 0.003. When x is 0.3, it is 0.067 and so on. Okay. So now let us see what is the x value given. This is the x value given. So this is 0.1 and what is the f of x? 0.003. Okay. 0.3. See, you can observe that x is equally spaced, that is h is 0.2, h is 0.2. Okay, this is equally spaced, equal distance. Okay, yeah. So now what is f values? So 0.67, 0.148, 0.248, 0.370. These are all given values here. See, f is given. This is nothing but y is equal to f of x. Okay. So this is 0.518 and this is 0.697. So now what is first difference? Delta f of x. So first difference, that is nothing but the difference of these two. Okay. It is 0.067 minus 0.003, and the second difference, that is this one, and the third difference is this, and the fourth difference is this, and fifth is this, and sixth is this. Okay. So now when you obtain this delta f, in order to get delta square, you need to find the difference between these two, and these two, these two, and these two. That means one will be reduced. Here 1, 2, 3, 4, 5, 6 are there, and here it will be 5. In the delta f, it is total 6 terms will be there, and here it is 5 terms, and it is go on decreasing like this. When it comes to delta square, I think let us see the table. So it will be in this alignment. So let us see the table. Yeah. So x and y values are same as we have taken. We have just to calculate delta f of delta f. Delta f nothing but y1 minus y0. So this difference, that is 0.067 minus 0.003 is 0.064, yes, and this difference 0.148 minus 0.067 is 0.081, and this difference 0.248 minus 0.148 is 0.100, and this difference is 0.122, right? This difference is 0.148, this difference is 0.179. That is what delta vector is. So now in order to get this delta square, that is delta of delta f of x, okay? So now already delta f of x is there, then apply delta for that. So if you take the difference between 0.081 and 0.081 and 0.064, then we are going to get 0.017. If you take this difference, we are going to this value, and this difference is this value, this difference is this value, and this difference is this value. Now we can observe that as I explained. So in each delta, when you are going to increase delta, this is going to be tend to narrow like this, okay? So this is what the table looks like. So when you take the third, that is third order delta, okay? So difference between these two, the difference between these two is 0.002, and these two is 0.003, and these two is 0.004. Difference between these two is 0.005. So when you take this difference, this difference, this is going to be 0.001. This difference is 0.001, this difference is 0.001, and ultimately you got 0. If you go for one more step, it is delta raised to 6, yeah, then it is going to be 0, 0. So this itself is 0, therefore we don't go for the next step, okay? Yeah. So this is what is called forward difference table, okay? So we shall see one more example. Construct the forward difference table where the function is given and x is from 1 to 2 with the step length h, that is equal to 0.2. So this is the step length h is given, and this is the starting value 1, so it is taken here, and this is the ending value, and this is taken here, okay? And each step length what is given 0.2, therefore this equidistance 1 and 1.2, 1.4, 1.6, 1.8 and 2. So what is the function given? F of x equal to 1 by x. So when you take x as 1, then f of x value is 1. When you take x as 1.2, then it is 0.33, and so on. So now what is the difference? First difference, so that is 0.8333 minus 1.000. What is the difference? Okay, so what is the difference? Please write that difference, right? So now this one, this second one, so this is 0.7143 minus 0.833, and this is 0.626550 minus 0.7143, and so on, okay? So this, if you construct this also, the structure of the table will be like this, right? Yeah. So you can have the values. So with the help of the calculator, you just go on finding the difference. If you find these two difference, then it will be delta f, this second one, third one, fourth one, and fifth one. And if you get the all four values, then delta square will have three values, delta cube will have two values, delta raised to 4 value one value, and so on, right? So we can try this, construct this table. So this is x value, minus 2, 0, 2, 4. Okay, they are equally spaced, equidistance. What is f of x is given? This is 4, 9. Okay, yeah. This is 9, 17, and 22. Fine. So what is delta f of x? So delta f of x, so that is 9 minus 4, 3. So how it comes? 9 minus 4, that is equal to 3, right? And this is 17 minus 9. What is 17 minus 9? Right? This is 8. And this is 22 minus 17. What is 22 minus 17? 5. Yeah. Now delta square f of x. So what is delta square f of x? Right. So that is 8 minus 3, which is equal to 5. And this is 5 minus 8, that is equal to minus 3. Right? And what is delta cube f of x? Again, take the differences. Take the differences. Right? Yeah. So it is minus 3 minus 5, which is equal to minus 8. So you can see that this is okay. So this is how we are going to find the forward difference table. This is nothing but the forward difference table. Okay. And in the next class we shall see what is a backward difference and the backward difference operator, backward difference table, and relations between the operators, etc. So I hope it is clear. In the forward difference table, we are just going to subtract y2 minus y1, y1 minus y0, and so on to get the first values, the first difference operator. For the second, we take the difference of these two, and for the third, we take the difference of these, then we get the required table. Yes? Yeah. So we shall meet in the next class. Thank you.